So break and continue statement in Python. So in Python, break and continue statements can alter the flow of normal loop. Normal loop means, well, let's say we have a for loop here. Let's say we have the for loop. So here we write the condition, right? And then we write this body of this for, right? And maybe if we have else, for with else, we write else part here. Okay, so when we exit this for loop, when the condition here becomes false, that's the way to exit this for loop. But sometime, that is normal exit from the for loop. But sometime we want to exit the for loop or while loop early. That means without this condition becoming false, we want to exit this for or while loop. So that time we will use break to break from the for loop or from the while loop. So let us see the break statement here. So here is the flow chart of break, right? So we enter the loop, we test the expression condition, right? If it is true, right? If it is true, then we ask when the condition is true, we enter in the loop, enter the body of the loop, right? So that is here while so the condition, if this is true, we are asking this question, we are testing this expression here. If this is true, we enter this body of the while loop, right? And then here in the body, if we have a break statement, like this, if we have this break statement, and if we want to break, right, we will exit the loop without. Now if we don't have break, we don't want to break, if then we will remain in the body of the loop, right? So we'll be remaining in the body of the loop. Then again we check the condition, and then again if the condition is false, we'll directly come out of the loop. If condition is not false, condition is true, then we'll enter the body of the loop and check for the break, right? And if there is a break, so we'll come out of the loop, right? Otherwise we'll continue in the loop, right? So this is what break statement. So let's take an example so that the things will be much clearer. So here is an example. Okay, so you see here we have this numbers array, right? Numbers list, right? Now we'll be iterating this list, right, with this variable number by using a for loop, for number in numbers. So this number will take value 1, 2, 3 and 4, right? So we'll be naturally exiting when when this list is exhausted. That means when the list ends, right, there is no more number left. So we'll exit the for loop. That's the normal flow of for loop. But if we want to break before, if we want to exit the for loop before reaching the end, right? So then we will use the break, right? So let's say we want to exit as soon as we reach. Let's say as soon as we reach this 4, we want to exit, right? So for number in numbers, if number equal to 4, is number equal to 4? No. If number is not 4, then we will not break. If number is 4, not 4, will not break. So we'll be in the loop. So we'll execute the next statement in the loop. That is this statement. This is first statement of the loop. This is second statement of the for loop. These two are in the body of the for loop. So we'll print number. We'll print 1. Right. Then we go up, and now number will take value 2. Right. So again we check, is number equal to 4? If number is not 4, this will not break. That means this condition is not true. If number is not 4, this condition is not true. We'll next go to the next statement, that is here. So we'll check, we'll print that number. That number is 2, we'll print it. Then again we go up, number now takes 3, right? So this number will iterate through this. This number will go through or traverse through this list, taking one value at a time. So number is 3 now, number is not 4. So again we'll not execute the break because this condition is false. So we'll print the number is 3, right? Again we go up, number now takes 4, number is 4. Now we come here and check, is number equal to 4? Is number equal to 4? Yes, number is 4 this time, right? Because number value is 4 and we are comparing 4 with 4, both are equal. So condition is true, we will break, right? We will not print the number, right? See, as soon as we encounter break, without executing any statement including else, without executing any statement including else, we'll break out of the for loop, right? So we'll go directly out of the for loop, and the next statement, the statement which is after for loop will be executed. So this is the statement which is after for loop, right? So we'll print this statement. That is what is being printed here, right? Okay, so this is the break, right? So let's see when the break is useful, right? Now the break makes the code more efficient, right? So now let's say we have a program here for finding or checking whether the given number is prime or not. So the logic for checking whether the given number is prime or not. Let's say we want to check whether 23 is prime or not. That's what we want to check, right? How will I check that? I will start from 2. I'll start from 2, 3 up to 22, right? And I will divide this 23 by each of these number, right? I'll first divide this 23 by 2. If this 23 is not divisible by 2, I'll continue. I'll go to 3. I'll divide this 23 by 3, right? If not divisible, right? I will, like that, I will divide this 23 by each number here, right? Right. Irrespective whether this is divisible or not, I will be dividing this 23 by each of the number, right? Okay, so that is good if the number is prime. What if the number is not prime? Let's say I want to check whether 22 is prime or not. So again, I'll use the same logic. Starting from 2, I'll be dividing this 22 by each number till 21. Right? 22 minus 1, 21. Here 23 minus 1, 22. Right? So I'll divide this 22 by 2, and if this 22 is divisible by 2, immediately here I know this 22 is not prime, because this 22 is divisible by some number, right? That means I need not divide this 22 by remaining numbers, which and if I do that's where I will be wasting time. So the point is, as soon as I find this number is divisible by some number, I'll break this task. I'll break this division, right? Let's see how to achieve that, right? By using break, I can achieve that, right? So here is so we'll take the number as input from the user, right? Then we'll set this is divisible to false, right? Is divisible false means the number is not divisible. The number is not divisible, right? So what is this? This here input will allow us to take the input from keyboard, right? So we'll write a message here, enter the number, that message, and we'll have the input box, right? So user will enter, let's say 21, right? So that 21 by default is a string. So we'll convert that 21 into integer by using this int. This is called as typecasting, right? So we'll convert 21 into int, yeah? And that 21, which is integer now, will be assigned to this number. Okay. So then I'll be starting from 2. Whatever number will be entered by the user, right? So if user enters number x, for example, so we'll be starting to divide that number from 2 till x minus 1. So this, in order for this x to be prime, this x should not be divisible by any of these numbers. For this x to be prime, this x should not be divisible by any of these numbers. If x is divisible by any of these numbers or all of these numbers, then x is not prime, right? Okay, so that's the logic for checking whether x is prime or not. Now the thing is here, as soon as I find some numbers divides x, I'll quit this, right? So the routine task here is divide this x by 2, divide this x by 3, divide this x by 4, so on and so forth till x minus 1, right? But what will we do? We will, as soon as we find this x is divisible by some number here, we'll break that division. We'll not go further. We'll not do this, right? Remaining divisions will not do. That's where we'll be saving the time. Okay. So now starting from 2, that's why I is started to 2, while I is less than number, right? I is less than number. If number is 24, I will be going from 2 to 23, right? I'll be taking values from 2 to 23. So this condition will be true till we reach to 23 if number is 24. Okay, now we'll check if number percent I equal to 0. If number percent I equal to 0, this percent gives us reminder. So number percent, if number percent I, that means the remainder, if the remainder is 0, that means the number is divisible by I, right? What we are checking? We are checking, is this x divisible by this? When I can say this x is divisible by this, when I get remainder as 0, that means x percent 2, x percent 2. If this is equal to 0, that means this x is divisible by 2. That's what we are doing here. Number percent I equal to 0, that means the number is divisible by I. We'll set that is divisible equal to true, and we'll print that the number, right, this will be replacing this bracket, this number is divisible by I, this bracket will be replaced by this I. This is formatting in Python, which we saw in earlier video. Okay, now as soon as I find this number is divisible, what will we do? We'll break. That means I will not divide this number again by remaining numbers, because I have just now I have confirmed that this number is not prime at all. Then why should I waste time, right? So I will not do remaining divisions, right? So I'll break. Now this break will take me directly out of this for loop, while loop, right? So what is where should I go out of this for loop? So while loop. So this is the statement which is outside of this while loop. This while loop body is still here only, right? So we'll come out of this while loop, and here I'll print what is the status of A is divisible. Is it still true or false? Now this is divisible will be true if we find that number is divisible by some number till number -1, right? So this is divisible will become true in that case, right? But if is divisible is false, the number is prime. So if is divisible means, this means if this is true, if this is true, number is not prime, right? If else, that means is divisible is false. It remained false. In that case, we'll print the number is prime. Okay, so that is how we can save time. But if I remove break, from here, right, we will be, though we found that this number is divisible by some of the numbers here, we'll still continue this division if we don't use break. If we use break, we can save our time. So that is one of the use here, right? Okay, so let's see the continue statement now. Now the syntax of continue. So here is the flowchart of continue. So again, we entered the loop. We'll enter the loop, right? And if the condition of the loop is true, we'll enter in the body. If we find continue, we neglect the other statements in the body of the loop. So let me write it here, right? So if this is while loop, while this is condition, right? Then we have the some statements here, and we have continue here, right? And then we have some other statements here, right? So now what happens is we check this condition, right? This is our test expression. We check this condition. If this is true, we enter the body of this while loop, and we execute this statement, this statement, this statement. As soon as I encounter this continue, I neglect the remaining statements in the body of the while loop, and directly I go from here to test the condition again of the while loop, right? So I check the condition again and continue in the while loop, right? And if I encounter continue, I'll neglect these statements and I'll keep, right? That means, of course, this continue will have with some condition. Here we might have some if condition, if statement here with some condition. If that is true, then only we'll execute continue. Otherwise, we will not execute continue. Otherwise, if we have continue without any condition, we'll always neglect these statements, right? So, but that's not the case. Okay, so let's see the example of continue, and then we'll understand better. Okay, so here is the example of continue. So we have these numbers here, right? This number list 1, 2, 3, 4, 5. Now what we want to do is we want to print, let's say, only odd numbers, right? Only odd numbers we want to print, right? So that means as soon as I find, see what I want to traverse through this list, and I want to print only odd numbers, right? I want to traverse through this list and I want to print only odd numbers. So for traversing, we'll use for, right? For loop, for number in numbers. That means this number will take this value, this value, this value, this value, and this value, right? So we are iterating through this uh, list, right, by using the for loop. Okay, so number initially will be 1 to begin with. This number will take this value 1, right? Now we check, is this number is divisible by 2. That means if number percent 2 equal to 0, that means when I divide this number by 2, do I get remainder as 0? If I get remainder as 0, that means this number is divisible by 2. That is an even number, right? So but now 1 is not divisible by 2. I will not, if I divide this 1 by 2, I will get remainder as 1. I will not get remainder as 0. That means this condition becomes false. So I will not execute continue, right? So if I don't execute continue, I will execute this statement, right? So I'll print the number. So that is what I got, the output. So from here I go up and then increment number to the next, take number to the next location, that is 2. So number becomes 2. When number is 2, again I enter the body of the for loop. In the body of the for loop, I have this first statement. I execute this statement, and this time I find number percent 2 equal to 0, because number is 2 and percent 2 will give me 0. So 0 equal to 0. So this condition is true. So that time what will I do? I'll enter this if block. In the if block, I have this continue statement. So this continue statement says, don't execute the remaining statements in this for loop, right? Go to the loop condition. Go to the loop condition directly without executing this. That means we will not execute this print statement. We'll neglect all the remaining statements after continue in the for loop, in the for body, right? So we'll not print this 2. We'll go up directly here, and then we'll increment number to 3. We'll take number to 3. Number becomes 3, and this time again we check, we find that this 3 is not divisible by 2, so we'll not continue, we'll not go into continue, we'll go to the next statement of if, that is print. So print number, so we'll print 3 here, right? So thus we'll execute the for block with continue, right? And at the end, you know, when we exit this for loop, right, when this list is exhausted, all the numbers are traversed by this for loop, we exit for loop and we go to else, right? In else block we have this, right, else block, right? So remember, break used to break out of the for loop, including else. Break will break out of the for loop, including, that means when we have a break, we don't execute else also, right? But with continue, when we find continue, we don't break the loop, but we neglect the statements which are after continue. The statements in the loop body which are after continue, those statements get neglected, right? And then we go to the condition, right, and we evaluate the condition again. If that is true, we remain, or we continue in the for loop, right? This continue literally says continue in the condition, continue in the loop condition, check the loop condition, go to loop condition, right? Okay.